विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
Indian Statistical Institute is a public university which is recognized as an institute of national importance. It grew out of the statistical laboratory set up by Prashanto Chandra Mohananobish in Presidency College, Kolkata. Established in 1931, this unique institution of India is one of the oldest institutions focused on statistics. Primary activities of ISI are research and training of statistics, development of theoretical statistics and its applications in various natural and social sciences. We welcome Professor Utpal Garain from Indian Statistical Institute, Kolkata. Professor Garain is working in the field of artificial intelligence. Let's hear from his own voice about his academic journey.
My name is Utpal Garain. I am a professor at Indian Statistical Institute, Kolkata. So my background is basically in computer science and engineering, and last about 25 years or more, I have been doing research in artificial intelligence. So I did my undergraduate in computer science and engineering from Jadavpur University in 1994, and then 1 year I was in industry, and then came back to academics, and I did masters in computer science and engineering again from Jadavpur University. And then I was in software company for a couple of months, and then decided to pursue higher education as a full-time job. So I joined Indian Statistical Institute in 1999, and then completed my PhD again in a very niche area of artificial intelligence in 2005. And after that, I received a postdoctoral fellowship from CNRS France. And then I did my postdoctoral study in University of Rouen. And then 2006, I was awarded Young Engineer Award by Indian National Academy of Engineering. And after that, for 1 year or so, I moved to University of Maryland in College Park for doing my postdoctoral research. And again, after a few years, I visited Osaka Prefecture University under JSPS Fellowship, and I take pride in telling you that this year I am elected as the Fellow of Indian National Academy of Engineering due to my contribution in artificial intelligence.
Professor speaks about AI, the most talked about phrase in today's digital world.
In today's world, everybody from a very small child to our grandparents, at least one thing they know is artificial intelligence, along with other things. So AI for artificial intelligence is not a very new thing. So if we look at the history, this term was introduced in 50s after Second World War, when World War II, when people understood that computers are becoming very powerful. So a community came and they introduced this term in mid-50s. Say, for example, that researchers like McCarthy, Minsky, and Licklider. And so idea was that can we configure machine that can behave like a human, right? But that time the expectation was very high. So the ideas, I should say, it was much hype, and that's why after a couple of years, then we call it the winter of AI. So basically, the ideas they thought that they could achieve, that was not achieved, and that's why people somewhat disillusioned about AI. But in last 10-15 years, AI got rebirth due to several factors. So one factor is that this availability of big data, and second thing is that the enormous development in cloud computing, internet working, and third thing is that some of the newer algorithms newer methods we got, so that now AI is basically in every home, in every industry, like that. So what is AI? Now today the way we define AI is that any machine that can do a task that requires intelligence, that can be considered as basically an AI program or AI application or AI tool. Say, for example, computer can speak, computer can give answer to any question, computer can understand the language you speak or you type, computer can say give you decision when you ask something. So anything, and you know that the spectrum of AI is really is a huge now today.
Professor Utpal Garain speaks on his own contribution to this area of research.
As far as our research in AI is considered, so in ISI, AI research started, we have a very, very long-standing history in AI research. So in late 80s, Professor Dijesh Datta Majumdar, the well-known figure in Indian science and technology, he got a big project from government that is known as KBCS. So stands for Knowledge-Based Computer System. And that was purely based on AI, but that time the term AI was not that popular. And later on, 90s onward, other researchers, so ISI has always played the very significant and pivotal role in AI research in India. Professor Vidyut Varan Chaudhary, Professor Shankar Pal, they also started AI research. So I joined in late 90s. And the first AI research, or I should say the research project I started, is known as optical character recognition. So what is optical character recognition? That time that the requirement of the industry was that, okay, if we talk about paperless office or if we talk about digital library, who will convert that all these paper document into typed form, right? So there are two ways out. One is that we can convert everything into image and keep in the server, or second thing that we can employ typist who will type all the paper material into computer, and so we will have editable text in the computer. Now both the ways were not basically feasible. Feasible in the sense, if we convert everything into image, that will take huge space. I mean, that much space is not easy to provide, and also images are not even today they are not easily searchable. Say you are looking for a particular writing or Rabindranath Tagore. I mean, you give a text, right? But if Rabindranath Tagore's writing is available in image format only, it is very difficult to give you the right prose or poetry or novel back to you depending upon your query. So other thing is that somebody will type everything, and that will be stored into computer as searchable text. Now that will require huge, enormous, human intervention and involvement. So the idea of optical character recognition came that is it possible that I will take image of a page and I will give it to the computer, and computer will look at the characters in the image and convert that text into editable document. So basically, so that is a very nice example of AI, that can I replace a human typist by designing a computer software, right? Now, for Roman script, for English, good research was that time available, but nothing was available for Indian perspective. For example, Bengali script, Devanagari script, and other script. So we took up this challenge that we will develop this. The main challenge was that in Indian script, the characters are connected through matra. So how to disconnect the word into characters, that become a challenge. And altogether, it was a very different technical challenge, different from Roman script. And we got very good success in designing OCR system for Bengali and Devanagari script. And the technology was transferred to CDAC Pune, and they started selling this product as name of Chitrankan in 2002. That was the first Indian script OCR system, and they acknowledge us. On the cover of the package, it was written that in association of Indian Statistical Institute, and we take pride in it that the entire code was written by us. So I took a very pivotal role in designing that OCR. Later on, CDAC Kolkata also took our Bengali OCR and they started selling it as Chitralika. So that was the beginning the research in my team, and then gradually we came into more language processing area. The reason was that we observed that there is a good amount of progress in processing other languages, mostly let's say English, German or French, and they are very resourceful language in the sense that a lot of technology that time, the researchers were developing. So we thought that, so why should we lag behind in processing Indic languages? And then we found that we don't have much resources for our own languages. So 2010 onwards, we started research in Indian languages, processing of Indian languages, and we started developing small tools like the speech tagger, because you know that language processing requires many grammatical knowledge. Say, for example, given a sentence, first identify that which one is noun, which is the subject, which is verb, which is predicate, and then to go down, which is noun, which is verb, which is adjective, etc., etc. And then we realized another problem with Indian languages is that it is very much agglutinative language. What is agglutination? In Indian languages, the problem is from a single root word, we have many words. Those are called surface words, what we read in the newspaper, right? So, for example, car. Now in Hindi, karenge, and many other inflections are there, which is not very prominent in English languages. So we developed one tool called lemmatizer. So even in Bengali also, say for car, from this car root word, there are 80 to 90 inflections. So we developed a tool called lemmatizer that will take a surface word. Surface word means the word form that you read to converting into that particular dictionary head word, because dictionary doesn't contain all the inflected words. So for example, in Bengali and Hindi, if you see that how many words are distinct, you will have a very big list of 400,000, right? But in a typical dictionary, how many words you will have entries for them? Around 50,000 to 60,000. That shows these 60,000 words are inflected, agglutinated to give this 4 lakhs different number of words. So that also became a very important project, and that was published in the best conference in the field of computational linguistics or NLP, that conference known as ACL. So we published this paper in 2018, that lemmatization for Indian languages.
Professor speaks on the next level of research.
Gradually, we moved to other fields, realizing the power of AI. We started up new research for last couple of years in the field of medical imaging, because medical imaging, that also because it's not very much today's, that AI models are not very much input specific, whether you give language as input or image as input. So realizing that, we thought that can we use this AI power for medical imaging also, and we started collaborating with TCS Research in the field of ECG analytics. So there the idea is that given an ECG signal, can machine identify the disease conditions, and machine can do with very high accuracy. We started another research with Doctors Trivedi and Roy Diagnostic Center, one of the best known pathology lab in Kolkata, along with Fortis Hospital. So there the task is, and that has a very high impact for our healthcare in rural areas, because there the hematologist observation is that when patients are coming from district towns to the city, let's say a patient with leukemia, there the hematologists, they identify that probably this is a 6-month-old case or maybe 1-year-old case. So district level pathologists, they sometimes miss the misidentification of the abnormal cells. So the project here is that this will be finally basically a mobile app that can be used by the district level pathologist, who will not miss probably the abnormal cells, and because machine will identify that this cell is abnormal and will generate a red flag, and the expert hematologist will be connected to the system, and immediately they will get a alert that for this patient this abnormal cell has been identified. So you just look at the image and give your decision. So these things are completely assistive tools to the hematologist and pathologist, because for mission critical applications, never these AI tools can replace human experts. Rather, they will use as the assistive tools for the pathologist, for the hematologist. So this is another area where we are getting very good success. And finally, the new question has come up in the domain of artificial intelligence, that okay, so machines are showing enormous accuracy. Sometimes they can surpass human accuracy also for many areas. But question is that is it sustainable? So for last 3 years we have started a new research that okay, so far the machine learning or AI depends on two things. You give input and you expect some output, right? So machines, what it learns is basically the correlation between input and output. But learning this correlation is not always sufficient to cater to the need in different domains. For example, a hematologist, let's say given an image that machine can identify that this is a blast cell, and hematologist appreciates this. Yeah, machine is doing very great, right? This is really a blast cell. But the moment the hematologist asks the machine that how do you arrive this decision that this is a blast cell? Now for a human pathologist can explain that why somebody is calling it blast cell, right? So let's say this is the shape of the nucleus, this is the shape of the cytoplasm, this is the color of the cytoplasm, etc. etc. So this is the need of the hour, that can your AI model give explanation which is understandable by human experts. So that is the newest challenge in overall in AI research. So we are following counterfactual analysis in the sense to find out what are the latent factors to give decisions. When machine gives decision, what are the latent factors machine identify for doing so the research the particular research area is counterfactual analysis. I give you one very funny examples so that you can understand that what is counterfactual analysis. Let's say you are collecting a data for country wise, that for a particular country, what is the amount of chocolate consumption per head and how many Nobel Prizes that country has so far got, right? Now you plot it, right? And then you find that there is a very good correlation that amount of chocolate consumption and the number of Nobel Prizes that particular country own. Now will you decide that to get more Nobel Prizes, you have to improve the chocolate consumption, right? So this is a very funny example that today's AI models can be fooled if you just depend on that data. So task is that you question AI models, that how do you arrive at this decision, and that requires explainability, that requires trustworthiness of the system. So this is our current research area, and so now to talk about that, okay, what are the utilities of this research what we have been conducting for so many years, more than 2 decades. So look at the applicability of OCR system, right? Now today, if you have, say you are reading something, right? And then if you like that text, particular writing, you will take an image using your mobile phone, right? But the image will take, longer space, much larger space than if you could type the text. So if you have OCR system, then and now it is available as mobile app, you just use OCR, then OCR will convert your image into the text as if you have typed that particular text that you, say for example, you are reading a poem and you like it, you want to keep it for your reference, right? Then that poem you can scan and send it to OCR system and OCR app, and OCR will give you as a typed text. So this is a small example, but you can understand that for making our offices paperless and also for automation in companies, that OCR has a great impact to play. And similarly, for language research, the local language has a very important role. Look at the ChatGPT and other large language models performance. They are very good for English, maybe very good for French and German, but what about our Indian local languages? So there we need our own research. That's why we conducted great stress we put on that is called TDIL, technology development in Indian languages, because unless and until we do it, nobody else will come and do it for us. Because language is our identity, language is basically our culture. So to develop our own language products, okay, we'll have LLM, but can we design our own models to assist the LLMs so that we get better results? So for example, if you go for translation today, right, you are running a business, let's say, and your customers are giving you feedback in Hindi, right? Now, how to do sentiment analysis that your restaurant is doing well or your hotel is doing, giving good services. So the large language models are not that great in processing Hindi languages or Bengali languages, or let's say even in Northeast, right? It's a very language rich region in India. And so LLM is not able to read a Bodo language, right? So that is one stress we put there, that we will have our own language models. And similarly, for medical image analysis research, you understand that for affordable healthcare, we need newer tools, and that is possible today because of the power of AI. So that district level patients or rural patients, they get the benefit of AI instead of that makes the treatment faster. They can start this treatment faster, and so these are the major impact of our research. So our research is always directed towards that end, where the question, whenever we take up a research, the question we ask, that is it socially relevant, right? So social relevance is the one driving factor for conducting our research.
Professor shares his view on India's ranking in the global context.
If you probably want to know about India's position in conducting this kind of research, so I should say that in India we are really going in parallel with the rest of the world. If you look at the state of the research in USA or in China or in Japan, so India is nowhere lagging behind. And also because of our great workforce, India, even in AI market, India is playing a big role. By providing intellectual input, by providing trained manpower. And if you look at that, so this is as a country, but as Indian diaspora, if you look at that, many of the models, they invented by, there are always many Indians in the team, right? And also the companies, the big companies who are becoming the leader in AI, many of these companies are basically, Indian workforce is a major workforce there, right? Now, as far as Indian companies are concerned, it is true that basically so far from Indian companies' perspective, we could not generate the great AI products that we have got from, say, US companies or other companies. But I think Indian companies will catch up soon. No longer will remain as just the user of AI tools, So that is my hope, because we have intellectual capability as well as, the right ecosystem. One lag is there, I think, the way different industry they spend money for academic research in other countries. In USA or other countries, that is slightly, lacking in India. That so scenario, I'm sure that very soon it will be a different scenario, and academic labs will get more funds from industry, so that the research will be more directed towards the industry need for social relevance. And in isolation, this is not possible. That is true, but the holistic development already we see, right? The development in hardware, software, in fact, that Indian companies, the way they are conducting their business. Thank you all.
We are really thankful for his excellent deliberations.